Get ready to write. Behind you. Yeah. Sebastian, where's your new notebook? All right, how do I use properties of tangents? Of a circle to a circle doesn't make sense. Your date needs to be at the top of your paper. I am tired of looking at your notes with no dates. You're going to get marked off in the last grade. Yes, ma'am. Let's talk about what it means to be a circle. A circle is the set of all points in a plane that are equidistant from a given point which is the center. It's a set of all points in a plane that are equidistant from a given point. That point is now called the center. What does it mean to be equidistant? Same distance. It's the same distance. You should probably, given point. Yeah, but you should probably listen and write at the same time. Because every time you pick up your head and look, you get further behind. All right, so now, just so you know, we have this is how we write it. We're not going to write out circle, just like we didn't write out the word triangle, we're not going to write out this word circle. This is how you call it by its name. It's called circle P. Whatever the center point is how you call the name of the circle. Okay? So let's draw a circle. We're going to go ahead and call it P in the center. So this is its center. Good so far? All right, let's keep going. Next word, radius. We're going to go back to our circle in a second. We're going to keep marking it up. But I'm going to define a lot of words, like 2 pages of words. So radius. Radius is a segment. What does it mean to be a segment? It's 2 points. Starts and stops. Like there's an ending and a beginning, right? So it starts and stops. So a segment whose endpoints are the center and any point on the circle. A segment whose endpoints are the center and any point on the circle. So here's the center, here's any point on the circle. We'll go ahead and call it right here. We'll go ahead and call this the radius. Next word is chord. This word chord is spelt differently than the chord you're actually talking about when you plug in something. Okay? This has an H in it. It's called a chord. A chord is a segment whose endpoints are on the circle. Back up to the circle. So from here to any other point on the circle, we'll go from here to here. We'll do this. And we'll call this a chord. It could be long. It could be super small. Okay? It could be anywhere. I could go across here. It doesn't matter. Okay? Okay. Next word. Diameter. You should know all these words already, yes? You learned them in IM1. God bless you. God bless you. All right, diameter is a chord that contains the center of the circle. Bless you. It's a chord that contains the center of the circle. Back up to the top. Here's your diameter. The diameter can go any which way as long as it goes through the center. It is a chord. Why is it a chord? Because its endpoints are where? On the circle. Is a chord always a diameter? No, but is a diameter always a chord? Yeah. Okay? We good here? All right, next word. Secant. Secant. A secant is a line that intersects a circle in 2 points. A secant is a line that intersects a circle in 2 points. Okay, a couple keywords in this sentence. What? Intersects where? 2 points. And what else? A line. Why do I care that it's a line? What have you been dealing with? Have you been dealing with lines this whole time? All the definitions above were what? They were all segments. This is not a segment, it's now a line. Okay? Next word. We're going to draw it in a second. Not on that circle, we're going to draw it in a different circle. I'm going to squeeze the circle. I'm going to actually put the circle on my margin just because I want it to be next to the definitions, okay? So, next word is tangent. I'm going to squeeze that in as best as possible. Tangent is also a line. So it is a line that intersects at 1 point. Is a line that intersects at 1 point. Keyword here, once again, there's a couple of them. What's one keyword? It's also a line, and it's how many points? 1. So I got to be careful, okay? We're going to draw this in the margin so you can see it together with the definition. Otherwise, it will be on a separate sheet of paper. So I'm going to draw it over here in the margin, yes? If yours is on the next page or at the bottom, that's fine. It doesn't need to be in the margin, only if you ran out of room and want to put it next to definitions. Got it? So draw a circle. Let's put a center, but we're not going to label our center because we're not really worried about the center. Our secant is a line. What is a line? How is a line different than a segment? What's the difference? It doesn't have endpoints and it goes on what? Forever. How do we know it goes on forever? What shows it? The arrows. Like that? All right, they're just secant. I'm going to use my ruler. Your tangent is going to touch how many times? Once.
I did not fix it.
I have all these pictures of Sierra doing random things.
There's a what? Ice pack?
No. But if you go next door and get a baggie, there's ice in the freezer. All right, tangent. Let me get the color. I can draw it anywhere, but I want to draw it separate than the secant so you can see it. It's literally going to touch with one little point located right here for my tangent. This point right here, we're going to go ahead and give it a letter. We're going to call it letter B. That is something special. That is called the point of tangency. In other words, where the tangent line hits the circle. So Ms. Morales' second period came up with an analogy today. We're going to use it because it kind of makes sense and it works. So, you know those violent films where you see people shooting each other? This is where the bullet intersects your body and goes through. This is the bullet when it barely grazes your body. And I was like, oh, that actually makes sense. Yeah. All right. So if you think of it however you want to think of it, but this goes all the way through, has 2 points, one located here, and your tangent only has 1 point where it barely skims the circle. Okay? Or the booty, according to. All right, ready? Next. I got 4 pages of notes, stickers. Circles are long. There's a lot of, okay, I'm going to tell you why they're long. It's not that the examples are long. The examples are pretty short. What's wrong is that I have to give you all these words to then do the examples. And it's kind of like that every day. So yeah. Words. Well, you should know words. All right. Next. My ear hurts. Common tangent. common tangent is a line, a ray, or a segment that is tangent to two coplanar circles. A line, a ray, or a segment that is tangent to two coplanar circles. First of all, what's a line? What does it have? Two arrows. What's a ray? A segment with what? One arrow. And then what's a segment? Not a segment, endpoint, sorry. A segment is what? Two endpoints. So a line, a ray, or a segment that is tangent to two coplanar circles. Underline the word coplanar, we're going to define it. You good? All right. Coplanar circles are two circles that intersect in 2 points, 1 point, or no points. Coplanar circles are two circles that intersect at 2 points, 1 point, or no points. If it's a 1 point intersection, they are called tangent circles. If it's only a 1 point intersection, it's called tangent circles. If they have a common center, so in other words, do you think the circles even touch? No, they're not going to. They're called concentric circles. Okay. So let's draw a picture. We're going to do 2 points. 2 points looks like what kind of diagram? A Venn diagram. There's your 2 points. 1 point can look 2 different ways. There's your tangent circles, because they're touching at 1 point. These are your tangent circles. Do you understand? The next one looks like this. There's your 1 point. Concentric is where you have the same center, and they're there. They're not touching. Good? All right, let's draw pictures of common tangents. Also, these are kind of long because we put a lot of pictures in it. Common tangents. 1 circle, 2 circle. Common tangent means it's going to touch both circles how many times? How many times are you going to touch a circle? What is how many times does a tangent touch one circle? Once. So how many times are we going to touch each circle? Each circle? Each circle only once. We're going to touch both circles, but we're only going to touch each circle once. So there's one. Two circles. Where else can I intersect or touch them? Where else can I have a tangent? We went through the middle. Where else? On the outside, so like where? On the top or on the bottom? We'll draw the top. Oops, a little crazy on my line. Questions? We good? A lot of words. Let's go to the theorems. There are two theorems you need to know. In other words, I have to give you the definition of the theorem, but it doesn't mean you have to memorize exactly what the theorem says. You need to know what it means, okay? So let's go to the theorems. The first theorem is called Theorem 10.1. Now, the reason why it's called 10 is because it's in chapter 10. The reason why it's called point 1 is because it's the first one. I know, so special. Theorem 10.1 says, a line is tangent to a circle if and only if. Now, I will not write if and only if ever again. The abbreviation for if and only if is IFF. Okay? If and only if the line is perpendicular. How do we write the symbol for perpendicular? That's parallel. How do we write the symbol for perpendicular? Upside down T. To a radius. So a line is tangent to a circle if and only if the line is perpendicular to a radius. Circle. Q. Tangent. Line M. Point P. Good so far? So it says a line is tangent to a circle if and only if. In other words, it's not a tangent if it's not perpendicular. Do you understand? If it's perpendicular, you have a tangent. That's what if and only if means. That the radius is perpendicular. What does it mean to be perpendicular? Form what kind of angle? A right angle. First type of example, here we go. It says verify a tangent to a circle. And it says is segment ST tangent to circle P. Didn't we just come out of a chapter of right angles? Yeah, what did they form? Right, what? What was that whole last unit on? Right triangles. So, guess what? Circle P angle am I trying to form? I'm trying to form a right angle. Where is the right angle supposed to be forming at? Is it going to be at S, at T, or at P? It's at T. Why T? Because where does the tangent have to be located? On the inside of the circle or the outside of the circle? On the outside of the circle. So what it's saying is, here's your circle, here's your tangent. Or we think it's tangent, right? For it to be on the outside, that's where the right angle has to form, because it's saying now your radius is forming that right angle. Okay? Does that make sense? So here's the tangent, here's the circle, but your radius is coming from the center to the circle to form that right angle. Got it? So your tangent needs to form the right angle, which is up here. So when I'm looking here, I want the right angle to be where? At T. Got it? Make yourself a note, because I'm not going to put the right angle in there because I don't know if it's a right angle. So I can't mark it. But I know that the right angle should be on the point of tangency. Keywords. Point of tangency should be where your right angle is being formed. So there was something I used in this last unit that said, hey, how do I know that what kind of triangle this is supposed to be forming? We don't need to use sine, cosine. Think about it. I want this to be what kind of triangle? A right triangle. What theorem tells me I have to use to prove it's a right triangle? Which one? Pythagorean theorem. What does it say, Pythagorean theorem say? C squared equals A squared plus B squared. Now the question is this. It's not that it's going to be equal. The question is it equal? If it's equal, then that's going to be tangent. Because that's what the theorem said. If it's not equal, is it a tangent? No. It might look like it, but it's not. Alright, so what's considered your C? 67, because I said, where do you want the point of tangency? Or where do you want the right angle? At the point of tangency, which is T. So that technically would be my right angle, right? So my hypotenuse is going to be over here, which is 67. Okay. It's also the bigger side. Okay, equals what's your A? 60, and what's your B? 25, or either way. I did it backwards, but it doesn't matter. Alright, what's 67 squared? I don't know, that's what a calculator's for. Okay, what's 67 squared? 4,489. We still have a question mark. What's 25 squared? Good, I already knew that. 60 squared? 3,600. What do you do with those two numbers? Add them. So I'm still asking myself, is it equal? What do you get when you add? 400? 4,225. Is it equal to 4,489? Do you have a tangent? Nope. Not a tangent. Make sense? Good. I'm going to make it hard. Example B. Circle T. Point S. R. 36. R. 48. This one says that this is a tangent. Do you understand? It's telling me they have a tangent. Wonderful. It wants me to find the radius of circle T. Okay. What does it mean to be a radius? From where to where? From the center to any endpoint on the circle. So the center to any endpoint on the circle. Why do you think I have the letter R there? What does R represent? The radius. Okay. How do we solve this? C squared equals A squared plus B squared is still correct. We're still going to do that. Okay. Let's start with A. What's A? No. Find where the right angle is supposed to be. Where is the right angle supposed to be? At what? No. At S. Supposed to be close to the what? To the outside. It's on the point of tangency, which is S. I'm telling you this is a right angle so I can write it in. Okay? So there's my S. There's my right angle. So where's the A? 48 is one of them. Plus R squared. You good? What's the hypotenuse? It's what? Let's use our brains really a second. The hypotenuse is always the what? The longest side. So can it really just be 36? Because this is what? This is, no, 36 needs to be, this needs to be the longest side. This is 48. That means this is missing something. Plus R. 36 is only from here to here. R is in here. So this whole thing is R plus 36 squared. Okay. How do we solve this? What does it mean to be R plus 36 squared? Oh, here comes first semester. Oh. What does this mean? You need to know, there's two R plus 36s. What does this mean? You add them together? How do you multiply them? You won't pass IM3. Come on, guys. You have to know these major skills coming out of here. There are three things you should know how to do. Factor, graph a quadratic, and your trig functions for the most part. This is part of the factoring, a little bit. Here, let me help you out. You ready? Yeah, where do my numbers go? Outside. What goes inside? R squared. What's R times 36? What's R times 36? What's 36 times 36? That's what you have a calculator for. Bless you. What is it? Louder, I can't hear you. 1,296. Thank you. Okay, now what do I do? Bring it out of the box. Oh my God, guys. I think you need a review on this. Good thing it's in your homework tonight. Yep. Now what do I put together? Like terms. So I get x squared plus 72r plus 1,296. You should have that on your paper. I'm just going to write that r squared plus 72r plus 1,296 is all I got. Yeah, look at that. I did all the rest of it on the board. All right. What's 48 squared? There are about 30 of you in here. You better learn how to use a calculator. 2,000. 304 plus r squared. Now, ladies and gentlemen, this is where you have to be careful. The goal is always to get the r squareds to the same set, because then that'll determine what I want the other side to equal. Do you hear me? Because if you're left with an r squared, that means you have to use that f word called factor, and you need that side to be 0. But if I cancel out the r squareds, then it doesn't matter, and I want the numbers on that side. Okay? So we need to be careful. Always move the r squareds first. So if I move the r squared, how am I going to move it? Subtract r squared. Oh, guess what happens? Cancels out, yeah? All right, I'm going to rewrite what's left. I have 72r plus 1,296 equals 2,304. Okay, if, and you might want to make a note of this, because I'm not going to do a problem like that today, but you might want to make a note. If you are still with an r squared here, you need to equal it to 0 on the other side, because then you need to factor. Do you hear me? If you are still with an r squared here, let's pretend there was a 2 and you subtracted and you got r squared. You need the other side to be equal to 0, so you can factor. Okay? But because this is not with an r squared, this is just a basic equation, how do you solve this? Subtract 1,296. So I get 72r equals 1,008. R is going to equal what? 14. Did I find the radius? Yes. Did you make the note I told you to write? Because you're going to have one of those, I think, in your homework. On purpose. Ready? We got to keep it going. Almost done. Here we go. These ones are easy. Theorem 10.2. Theorem 10.2. It says, tangent segments from a common external, what does it mean to be external, outside point are congruent. Tangent segments from a common external point are congruent. What does that mean in terms of picture? It means here's your picture. Here's circle P. Here's tangent RS. Here's tangent TS. It means that segment SR is congruent to segment ST. Example 2. What does that mean? That means that here's my circle C. That A to D is 25. Doesn't this look like a cone hat? And that BD is 6x minus 8. 6x minus 8. I am letting you know that segment DA and segment DB are tangents. If they're tangents, then I know they're what? Says it up at the top. They're congruent. So they're tangents. I want you to solve for x. How do you solve for x? If they're congruent, what do you know about AD and BD? What's the key word? If these are congruent, then their values are what? What's the word for same? In math. Besides congruent. Equal. Because we're dealing with numbers now, right? So if their segments are congruent, then their lengths are equal. So is 6x minus 8 going to equal 25? Yeah, it is. Are you going to be able to solve that? I hope so. What do? Add 8 and you get 6x equals what? 33. And then you divide into x equals, ooh, it's a decimal, 5.5. Does that make sense? Okay? These ones are easy. The other one's a little bit harder, especially if they put in R. There's going to be some with R and some without. That's why I did one of each. I didn't do a factor one, but I am going to let you know. Down at the bottom. Your homework is in the book. It's page 655. You're going to do a lot of book work for most of this unit. It's numbers 3 through 10 and 18 through 25. I'm letting you know that number 25 has 2 answers. The only reason it's probably going to have 2 answers is because that F word factor might be useful. You understand? Now listen very carefully. 3 through 10 is all vocab. That's nothing difficult. But you must draw the picture, okay? So what I want you to do is I want you to fold your paper in half. When you fold it in half, you'll do 3 through 10 up here. You can put all 3 through 10 here and draw the picture over here, right? So it's all together. Make sense? And then you can cut the rest of your paper into 4s. Okay? So 3 through 10 is going to be here. And then 18, 19, 20, 21, 22, 23, 24, 25. Got it? So really it's not that much. 3 through 10 is all vocab. Okay? We good? You're done. It was a lot. I would start to write stuff in your notes, especially if you're stuck on something or want to ask a clarifying question. Should be a question also